This video presents declassified and licensed material of the Global Institute of Logic and Cybernetics.
Modern technology relies on three disconnected pillars. Physics lacks a formal observer model, biology lacks a multiscale mathematical framework, and artificial intelligence relies on data without physical grounding. This fragmentation prevents us from closing the loop between experiment, model, and control. To bridge these gaps, we are implementing a fabric-first ontology called Quantum Biological Intelligence Infrastructure, or QBII. This framework maps open quantum field dynamics directly to biological structures, creating a unified substrate for recursive intelligence. Correcting the fragmentation problem requires more than software. It requires a measurable grounding in physical reality. By embedding recursive observer structures into quantum biological systems, we create a stable, testable environment for intelligence to operate. This architecture provides category-theoretic closure. It formally maps quantum fields to biological transport and observer dynamics. Here, intelligence is a recursive fixed-point invariant. We replace subjective definitions with measurable structural convergence in a state space, governed by strict admissibility gates. To prevent infinite invalid recursion, the architecture employs an ordinal rollback engine. If the system enters an inadmissible state, the engine forces a descending recovery to the last anchored stable point. These rigorous mathematical constraints are designed to provide the deterministic auditability required for high-stakes infrastructure. This creates the formal basis for a system that remains stable under multiscale execution. We are moving from formal proof to physical execution with the BG01 pilot node in Sofia, Bulgaria. This facility investigates three specific quantum biological anchor systems: hydrogen tunneling in enzymes, excitonic transport in photosynthetic complexes, and radical pair magnetosensitivity. Data from these experiments stream into codex station servers to create a closed-loop digital twin. This validates the physical signal against the simulation, verifying the energy, topology, and identity of the system in real time. This continuous, falsifiable loop between measurement and reconstruction provides the evidence required to validate the theoretical model and ensure system stability. The validated BG01 node serves as a production template. Its configurations and invariant gates can be replicated across a distributed node network. Scaling is managed by the Scroll Agent Runtime, an autonomous engine that coordinates recursive observer kernels across diverse hardware environments. Every new node operates under a zero-trust architecture. Strict invariant gating ensures that state updates only propagate if they meet the formal admissibility requirements of the constitutional core. This scaling mechanism preserves the integrity of the whole network. A failure or adversarial breach at a single node is contained immediately by these mathematical gates, preventing systemic collapse. Fully standing up the BG01 pilot node requires a Phase 1 capital requirement of $450,000 to $1 million. This equity is structured across 5 distinct asset classes: physical laboratory infrastructure, validated quantum biological datasets, algorithmic kernels, sovereign protocols, and the integrated IP stack. Capital is released strictly against physical deliverables. Funding is tied to the confirmation of quantum biological signals, stable state reconstruction, and the achievement of closed-loop twin stability. Funding the BG01 node establishes the first operational link in a new category of physical intelligence infrastructure. It secures a foundational stake in a mathematically sound system designed for sovereign scale validation and execution.